Our lesson today is to be able to solve two-step equations. When we solve two-step equations, we want to use the order of operations in reverse. A two-step equation is an equation where you will see two operations. If we look at this example here, 2 times the number x plus 3 is equal to 9. We see multiplication here, I see addition here. Two operations means that to find the solution, we'd have to do the inverse of each of those two operations. Alright? For this example, we would have to undo the subtraction first, and then we would undo the multiplication. Alright? So let's take a look and see what that's going to look like. Alright? So we have 2 times the number x plus 3 is equal to, oops, that's supposed to be 9. Right? Is equal to 9. Right? I see two operations. First, I want to undo the addition or subtraction first, and the reason for that is it just makes solving the equation easier. Right? You can undo the multiplication first, but it makes the problem, the computation, a lot more difficult if we undo the multiplication first. So you want to undo the addition or subtraction first in a two-step equation, almost always. Right? So we're going to subtract 3 because we're doing the inverse of this addition. That's going to become 0. We're left with 2 times the number x is equal to 6. The inverse of this multiplication is division. We divide by 2 on both sides of that equation. X is going to be equal to 3. We check our answer. 2 times the number 3, or 2 times 3 is equal to 6, plus 3 is going to be equal to 9. Alright. Let's look at our next example. Another two-step equation because I see two operations. I see multiplication here, I see addition here. So we're going to do the inverse of those operations to find a solution. So we're going to subtract 5 using the subtraction property of equality. On the left side of the equation, these are opposites. That's going to become 0. So we're left with negative 3 times the number x on the left side of the equation. And on the right side of the equation, 2 take away 5 is going to be negative 3. We want to undo this multiplication. So we do the opposite, which is division. On the left side of the equation, negative 3 in the numerator will cancel the negative 3 in the denominator. So we're left with 1x is equal to negative 3 divided by negative 3 is positive 1. We check our answer. Negative 3 times positive 1 is negative 3. Negative 3 plus 5 is going to be equal to 2. Alright, so we have 3 examples here. Alright, first I want to identify the operations and then do the inverse of those operations to find a solution. Alright, I see multiplication here, I see addition. We see 2 times the number x plus 12 is equal to 4. We want to do the inverse of those operations. So first I'm going to take away 12 from both sides of the equation. On the left side, that's going to be 0. We're left with 2 times the number x is equal to. Here I have opposite signs, so I subtract their absolute values. That's going to give me 8. But because I have more negative than I do positive, it's going to be negative 8. Next, we do the inverse of the multiplication operation here. So we're going to divide both sides of the equation by the same value, which is going to be positive 2. On the left side of the equation, 2 in the numerator will cancel 2 in the denominator. It's going to leave you with 1x is equal to negative 8 divided by 2 is negative 4. Check that answer using substitution. So I'm going to replace x with negative 4 in that example. 2 times negative 4 is going to be negative 8. Negative 8 plus 12 is equal to 4. Alright. So I know that that solution is correct because it is the only value for x that's going to make the equation true. Alright. Next example, negative 5 times the number c plus 9 is equal to negative 16. We want to do the inverse of those operations. So we're going to subtract 9 from both sides of the equation. It's going to be 0. Negative 5 times c is going to be equal to negative 16 and negative 9. That's negative 25. When the signs are the same here, we add their absolute values and keep the sign the same. Right. Next, we do the inverse of the multiplication, which is division. Right. They cancel. That's going to be positive 1. C is equal to negative divided by negative is positive. 25 divided by 5 is 5. Check our answer, see if it makes the equation true. So I'm going to replace c with 5. Negative 5 times positive 5 is negative 25. Negative 25 plus 9 is negative 16. So I know that that is correct because it makes the equation true. Next example, I see this difference in parentheses here being multiplied by the number 3. So we have to use the distributive property first with this type of problem. So we multiply 3 times the number x is 3x. 3 times 4 is 12. That's going to be equal to 9. Now we have our two-step equation where we're going to do the inverse of the two operations. So I'm going to add 12 to both sides of the equation first. Over here they cancel, that's going to be 0. 3 times the number x is equal to 9 and 12, that's 21. Next we divide by 3 on both sides of the equation. Right, x is going to be equal to 7. I check my solution using mental math by replacing x with 7, see if it makes the equation true. 7 minus 4 is 3. 3 times this 3 is going to be equal to 9. So I know that that is correct. This next example, two-step equation with rational numbers, a whole bunch of fractions, we have different denominators. There are a lot of different ways to do this problem, but I prefer that my students use the multiplication property of equality to get rid of the all of the fractions in the problem. So let's see how that's going to work. When I have an equation with multiple denominators, I use the least common multiple of the denominators. Well, the least common multiple of 8 and 2 is going to be 8. So I'm going to use 8, and I'm going to use the multiplication property of equality, which says if you multiply both sides of an equation by the same number, the equation remains true. Well, on the left side of the equation, we have two terms. So each of those two terms has to be multiplied by 8. So I like to put an 8 in parentheses above each of those two terms. On the right side of the equation, there's only one term. So just that one term has to be multiplied by 8. On the left side of the equation, 8 times x is 8x. 8 divided by 8 is 1. Or you can look at it this way. 8 in the numerator is going to cancel 8 in the denominator. We're left with 1x. Minus 8 times 1 is 8. Divided by 2 is 4. Right, and all I'm doing there is multiplying this number times the numerator and then dividing by the denominator. Right, and that's going to be equal to 8 times 7 is 56. 56 divided by 2 is 28, but that's going to be negative 28. Now we have a one-step equation, so I'm going to add 4, right, using the inverse operation to both sides of the equation. X is going to be equal to negative 24. All right, I can check that answer, right, see if that works. Negative 24 divided by positive 8, that's negative 3. Negative 3, take away another half, is negative 3.5. Is negative 3.5 the same as negative 7 over 2? The answer to that is yes. Alright. Well, now we have 3 problems down here where each of these problems are have fractions involved. And once again, there are different ways to do the problem. Alright, I like to do these problems by using the multiplication property of equality to get rid of the fractions first. Alright, so that's the way we're going to do each one of these. Well, I have an equation with a fraction, and I want to rewrite this equation without fractions, so I'm going to use the multiplication property of equality. Because I have a denominator of 2 and there's just one fraction, I'm going to use that value of 2 and the multiplication property of equality to multiply both sides of the equation by that 2. Well, over here with this first term, 2 in the numerator is going to cancel 2 in the denominator, so I'm left with 1m plus 2 times 6 is 12 is equal to 2 times 10 is 20. The common mistake if you're using this method is sometimes students forget to multiply each of the terms of the equation. There are 3 terms in this equation, 2 terms on the left side of that equal sign, 1 term on the right side of the equation. Each one of those terms has to be multiplied by 2 if you're using the multiplication of property of equality correctly. Now I just have a one-step equation where I'm going to subtract 12 from both sides of the equation. That's going to give me 0, so m is going to be equal to 8. I check my answer. 8 divided by 2 is 4. 4 plus 6 is going to be equal to 10. Right, I see that it makes the equation true, so I know that that's the solution. Our next example, Once again, I see a fraction here. I want to rewrite this equation without fractions. I see that the denominator is 3, but I have the negative sign in front, right? So I'm going to multiply each one of these terms by negative 3 just to get rid of the negative and the 3 at the same time. Negative 3 in the numerator is going to cancel that negative 3 in the denominator, so I'm left with 1z plus, negative 3 times negative 5, that's negative 15. Well, instead of writing plus negative 15, I'm going to write minus 15. And that's going to be equal to negative 27 because negative 3 times 9 is negative 27. I solved that equation by adding 15 to both sides of that equation. That's 0. So z is going to be equal to, what's that, negative 12. I check my answer. Negative 12 divided by negative 3 is positive 4. Positive 4 plus 5 is equal to 9. Right, so I see that that's the solution because it is the value that makes the equation true. All right. Next example. I have multiple fractions in here, but they have the same denominator. So I'm going to use that denominator of 5 to multiply each one of my terms. Here, 5 in the numerator is going to cancel 5 in the denominator. I'm left with 2 plus 5 times 4a is 20a is equal to, here the 5 in the numerator is going to cancel 5 in the denominator, and I'm left with negative 6. Next, I'm going to subtract 2 from both sides of the equation. That's going to be 0. We're left with 20a is going to be equal to, that's negative 8. And then when we divide both sides of that equation by 20, they cancel. A is going to be equal to, what's that, negative 4 over 10, right, which would simplify to negative 2/5. All right? Right, we'll do a couple more examples here. Right, this next example here, we have like terms and like terms have the same variable to the same power, and they're on the same side of the equation. So before we start using our inverse operations, I want to simplify the left side of that equation by combining the like terms. 3y minus 8y, that's going to be negative 5y, or if I add the opposite, it's 3y plus negative 8y, negative 5y. That's going to be equal to 25. So once I combine those like terms, I get a one-step equation. I use the inverse operation. Right, so I'm going to divide both sides by the negative 5. They cancel. Y is going to be equal to negative 5. Circle or box that answer. Right, I check it. 3 times negative 5 is negative 15. 8 times negative 5 is negative 40. Is negative 15 minus negative 40, which becomes negative 15 plus 40, right? And that's going to be equal to 25. All right. We're going to move on to, let's see, okay, we'll take a look at these examples down here, right, where we have to do some combining of like terms first before we start using our inverse operations, right? If I look at this problem here and I underline my like terms, that's a positive 4 and a positive 3. That's going to be positive 7, right? So we wind up with negative 2y plus 7 is equal to negative 9. So when I combine those like terms, I get my two-step equation. I can use my inverse operations. Subtract 7. They cancel. Negative 2y is going to be equal to negative 16. Divide by negative 2. Divide by negative 2. They cancel. Y is going to be equal to 8. Right, next example. 7x take away 10x. That's going to be negative 3x is equal to 15. We have a one-step equation there. Divide by negative 3. Divide by negative 3 on both sides of the equation. X is going to be equal to negative 5. Circle or box your answer. All right. Last one. I have my like terms on the right side of the equation this time, so I'm going to recopy the negative 8. But 1 and 3/10 take away 2 and 1/10. Well, they're opposite signs, and we're subtracting, so I have to use the additive inverse, and I see that they're opposite signs. So I have to go to the side of my paper, take 2.1, take away the 1.3, but I know that my answer is going to be negative, right? Because I'm adding opposite signs, but I have more negative than positive. All right, when I do that, that's 1, that's 8, right? And we wind up with negative 8/10. So negative 8 is equal to the negative 8/10 m. And when we divide by the negative 8/10, divide by negative 8/10 on both sides of the equation, they cancel, and that's going to be what? Negative divided by negative is positive. That's going to be 10 is equal to m, right? We circle a box, that answer. All right. I have a few more examples to look at here, all right, and we'll do that, and then I think we'll be all done. We have opposite operations, or I have multiplication, I have addition. We want to do the inverse. Subtract 3, they cancel. 2 times the number x is equal to 6. Divide by 2, they cancel. X is equal to 3. All right, our next example. We have multiplication, we have addition. We want to do the inverse. So we're going to subtract 2, they cancel. 3 times the number x is equal to 21. Divide by 3, they cancel. X is equal to 7. Next example, I have multiplication and subtraction. We do the inverse of those operations. So we add 7 to both sides of the equation, they cancel. Negative 2y is equal to 10. Divide by negative 2, they cancel. Oops. They cancel, and we wind up with y is equal to negative 5. Right, and then our last example here, we have that fraction. We want to multiply both sides of the equation by the same non-zero number. So I'm going to multiply the left side of the equation by 5. I'm going to multiply the right side of the equation by 5. On the left side of the equation, you have 2 terms, so make sure you multiply each of those 2 terms by that 5. 5 times 4 is 20, plus, they cancel, 1r is equal to negative 5. Subtract 20, they cancel, r is equal to negative 25. Check our answer. 1/5 of negative 25 is negative 5. 4 plus negative 5 equals negative 1. Alright? So the bottom line here is, guys, make sure you first recognize the operations in the problem, in the equation, and then you're going to use the inverse of those operations to find the solution. Alright? And that's the end of the lesson. Good luck.